The surface of the Earth is no longer a survivable battlefield. For thousands of years, militaries relied on distance and camouflage to protect their most valuable assets. But in an era where synthetic aperture radar can see through clouds and autonomous drone swarms can loiter for days hunting for thermal signatures, hiding is a mathematical impossibility. If an asset is on the surface, it will be found. And if it is found, it will be destroyed. Because of this chilling reality, the world's superpowers have quietly agreed on one tactical doctrine. The only armor left is millions of tons of solid rock, command centers, nuclear refinement centrifuges, and ballistic missile silos are no longer being built out of steel and Kevlar. They are being buried inside solid granite mountains. Welcome back to our channel. Today we are analyzing the most extreme, highly classified engineering arms race on the planet, the Subterranean War. How do you construct a self-contained apocalypse-proof city hundreds of feet below the surface? And more importantly, how do you design a weapon heavy enough and smart enough to crack it open? The rules of engagement underground are dedicated by sheer terrifying physics. To understand the weapon that can shatter a mountain, we must first decode the anatomy of the fortress it was built to destroy. You see, a deep underground military base, or DUM, is not simply a bunker. It is a highly engineered, self-sustaining ecosystem designed to survive a direct nuclear strike. The first layer of defense isn't technology, it's geology. These facilities are intentionally bored beneath hundreds of feet of solid, unyielding granite or limestone. The rock itself acts as a massive kinetic sponge, meant to absorb and dissipate the shockwaves of surface detonations. But solid rock transmits seismic waves incredibly efficiently. If a massive explosion goes off on the surface, the rock will aggressively carry the violent vibration directly into the bunker, shattering concrete and killing the personnel inside instantly. To counter this, modern subterranean fortresses employ seismic isolation. The internal structures, the actual command floors and laboratories, do not touch the cavern walls. They are built as free-floating buildings inside the hollowed-out mountain, suspended on giant industrial shock absorbers and massive steel springs. When the shockwave hits the mountain, the cavern violently shakes. But the building inside simply sways, preserving the microscopic tolerances required for ballistic missile computers and nuclear material processing. Furthermore, these facilities are completely severed from the outside world. They draw their electricity from internal geothermal generators or miniaturized nuclear reactors. Their air is scrubbed through complex chemical-biological filtration systems. To the engineers who built them, a mountain fortress is considered impenetrable. It is a masterpiece of defensive architecture. But what happens when the attacker figures out how to use the mountain itself as a weapon? So, if you want to destroy a facility buried under 200 feet of rock, dropping a traditional explosive on the surface is entirely useless. You must deliver the warhead deep into the earth before it detonates. Enter the Massive Ordnance Penetrator, or MOP. This is a 30,000-pound smart bomb. It is so heavy that only specialized heavy bombers can carry it. But the secret to the MOP isn't its explosive yield. The secret lies in its metallurgy and its kinetic energy. Over 80% of the weapon's massive weight is just the casing itself. It is forged from highly specialized, ultra-dense steel alloys. The physics problem is terrifyingly complex. When 30,000 pounds of steel hits solid granite at supersonic speeds, the extreme deceleration forces usually cause the bomb to shatter like glass, or wrap so violently that the internal explosive prematurely detonate on the surface. To prevent this, the casing of a bunker buster is engineered to be stronger than the rock it is hitting. It uses sheer, unadulterated gravity. Released from 40,000 feet, the aerodynamic fins guide the massive steel spike to a pinpoint GPS coordinate, accelerating it into immense velocities. When it strikes the mountain, it doesn't blast a crater, it punches a hole. The hyper-dense casing physically forces its way through up to 200 feet of reinforced concrete and solid granite, remaining entirely intact. But punching the hole is only half the equation. How does a bomb know when it has reached the target, rather than just burying itself uselessly in the mud? Well, you see, a bunker buster is equipped with a piece of technology known as a Hard-Target Void-Sensing Fuse. This is essentially an onboard accelerometer and a microcomputer that rides inside the tail of the bomb, protected from the crushing impact forces. As the weapon violently burrows through the earth, the fuse measures the exact deceleration friction. It knows exactly what material it is passing through based on the resistance. The fuse can literally count the floors of an underground facility. An operator can program the bomb before the flight, instructing it to punch through the mountain, break through the first layer of reinforced concrete, ignore the first empty room, punch through the floor of that room, and only detonate when it detects the second void, the main command center. The weapon doesn't find the bunker, it navigates the architecture, it breaches the inner sanctum. And then the physics of the subterranean battlefield turn incredibly grim. Because when the fuse finally triggers the explosive payload, it isn't the fire that neutralizes the target. It is the pressure. You see, when a conventional bomb detonates on the surface, the energy expands outward into the limitless atmosphere. The pressure dissipates quickly. But when you detonate thousands of pounds of high explosives inside a sealed subterranean concrete box hundreds of feet underground, that energy has nowhere to go. This explosion creates a phenomenon known as extreme overpressure. The blast wave hits the reinforced walls of the cavern and instantly rebounds, colliding with itself. The air pressure inside the facility spikes so violently and so rapidly that the atmosphere itself essentially liquefies. For any personnel inside, the results are catastrophic. The sudden spike in barometric pressure causes internal organs to rupture instantly. But the pressure also weaponizes the bunker itself. Even if the walls don't collapse, the immense shockwave traveling through the concrete causes the inside face of the walls to violently shed layers of high-velocity stone and steel. This is called spalling. The room literally turns into a giant fragmentation grenade, spraying the occupants with lethal concrete shrapnel. From the surface, a subterranean strike is deeply unsettling. There is no massive fireball. There is no sprawling crater. Just a heavy seismic shudder that shakes the earth, followed by silence. The mountain remains completely intact, but everything inside it has been erased. This is the ultimate, unsolvable equation of modern kinetic warfare. As drones and satellites make the surface uninhabitable, militaries are forced to dig deeper, spending billions to hollow out the earth and build thicker walls. But for every foot of concrete poured, aerospace engineers simply forge a denser casing and add more altitude to the drop. It is an endless race between geology and gravity. A quiet, terrifying war being waged out of sight, where the ultimate prize is simply finding a place on Earth where the sky cannot touch you. And right now, gravity is winning. Thank you all for watching. If you liked this video, don't forget to give it a thumbs up, subscribe to our channel, and hit that notification bell.